All right, ladies and gentlemen, let's go and take a look here again and remember. And remember what you're going to do here. So if we have, right now I'm multiplying this rational expression by another rational expression. Now notice, there's no other operation except for addition and subtract, or sorry, addition, sorry. There's no other operation except for multiplication and division, correct? Yes. All right, that's going to be very important because we know that multiplication and division, we can distribute amongst them. What I'm saying is I can simplify. I don't have to say 2 over 15. That doesn't simplify. But I can say, I can rewrite this and say, well, negative 2 and 14, that does simplify, though, doesn't it? So since you have multiplication for these two monomials, we can distribute. So what I can say is negative 2 over 14, I can reduce that to 1 and 7. 15 over 5, I can reduce to, I can divide a 5 into both of those, right? Which reduce this would be to 3 and that to a 5.
What would that person be? Negative 7? The 1 or the 7 would be negative.
Yeah, it doesn't matter where the negative is. Right now, the negative's upstairs, so I'll leave it upstairs.
So it would be negative 1?
Yeah, so you can leave it as negative 1, yes. Cool. Then I also noticed, what about y divided by y squared? What happens when we have a y up top and a y squared on the bottom? What do? Right. So that would be y to the first minus 2, right? Which would be what? Yes? Yeah. So remember, and that's the same thing as 1 over y to the first, right? Yeah. So what I can say is, then this would go out, and that becomes a 1, right? X cubed over x, that's pretty much like saying, x cubed over x is like saying x cubed minus 1, which is equal to x squared. So then that would simplify. And that's all I have. Oh, and the u's. So now the u's, that would go to 1, and that would simplify out, right? Because I have u3, u to the third power over u squared. That just equals u, right? So therefore, I can say that's u to the first power, and that would divide out. So I do all this work up front, because then I don't want to have to multiply everything and then try to do it. But you can. You can multiply everything out and rewrite it. But now I have a negative u to the first power, that y got divided out, times 5 times x squared, all over 3 times 7, which is 21. Then I have z to the fifth and y to the first. And then usually we'd rewrite this again, which would be a negative 5u x squared over 21 z to the fifth y. And then you notice at this point, I cannot simplify it any further. Yes?
Why is the u negative? Shouldn't it be like, if it was negative 1, shouldn't it be 1 over u? Yeah.
Yeah, but it's u to the third power over u squared. So you subtract those, which would give you u to the first power, which means it remains in the numerator.
Wait, no, if you subtract 3 minus 2, no, it should equal
you get u to the first power. So that means the u remains up top.
Yeah. Negative 1.
Right. See, this one I did y, which is 1 minus 2, which would be negative 1. That's why the y went to the bottom, to the denominator.
But
yes?
You forgot about, because negative 2 divided by 2 would it be something 1? I don't know. You forgot the 1 that above the negative 2. You
okay.
Forgot that.
What I did, remember, it's multiplication, right?
Yeah.
So negative 1 times 5 is a what? It's a negative 5.
Yes.
Because remember, it's all multiplication.
Okay.
So the 1 times 5 is not going to affect anything. Does anybody have any?
Do we write down a negative 1?
Yeah.
All right, cool. Because I got the variable part right, just not the numbers. Because I got like 200.
So just remember, since we all have multiplication, you can distribute them amongst your two monomials. You can rewrite it. You can multiply all this across and rewrite it as one monomial and then do your simplifying. But since multiplication is distributed, you can now distribute amongst your two monomials since you're multiplying them. Now, that brings me to my next point, which is the